today we're going to learn another way to look at the probabilities for something called a probability tree. We'll still use probability tables, and if you have two events, a probability table is usually the easiest way to do it, at least I think it is. Probability trees are usually used for when you have more than two events. Now this first one is just two events. This giant wheel is divided into 5 equal sections labeled -2, -1, 0, 1, and 3, just to be weird at the end. At the double spin, players spin the wheel shown at right 2 times. The sum of their spins, that means we're doing what with the two numbers? We're adding them, determines whether they win. Make a list of the possible sums you could get. Well, you can either start with the least or the greatest if you want to kind of do this in any kind of a systematic way. If you rolled 3 twice, that'd be 6. And then I just start going down. Can you get 5? No. Could you get 4? Yep. You could get 3, doing a 3 and a 0. Can you get 2? By doing what? 3 -1. What's another way you could do it?
2 -2. Wait. No, 1 + 1.
How about 1 and 1? Right? Can you get 1?
Yes.
Yes. Can you get 0?
Yes.
Can you get -1? Yep. Can you get -2? Can you get -3? Yep. Can you get -4? Yeah. -2 and -2. Now the question is, are all those equally likely? The answer is no, they're not all equally likely. Some of them are more likely than other ones. So, one of the questions we might have is, which sum do you think will be most profitable? In other words, or most probable? Which one are you going to win the most times with? Is it easy to tell from this? No. Take a wild guess. It doesn't matter. Write down what you think. Just one number. Write it down. Don't spend a lot of time analyzing it. Just write down a number. It doesn't matter if you're wrong. So out of these, which one do you think is the most probable? All right, so let's create a table. So for our probability table, we're going to have 2 different rolls, right? And the possibilities for the first roll are, and I like to put them in order. Do you want to go greatest to least or least to greatest?
Least to greatest.
Least to greatest? Okay. So -2, -1, 0, 1, and 3. And let's do the same thing over here. -2, -1, 0, 1, and 3. I'm going to go ahead and add lines to mine. Otherwise, I tend to get kind of messy. I'm sorry? Oops, what the heck happened there? That's weird. All right, and then let's fill in the sums. So let's see, this is -4, -3, -2, -1, and 1. And then this will be -3, -2, -1, 0, and 2. So this will be -2, -1, 0, 1, and 3. This is going to be, what, -1, 0, 1, 2, and 4. And this one's going to be 1, 2, 3, 4, and 6. Now, if you hand draw this like this and you've drawn all these things, you may want to somehow or another make these darker so it doesn't look like just a whole bunch of numbers. All right, somehow or another section those off. Okay, so how likely, what's the probability of getting a -4? What's the probability of getting -4? How many -4s are there in the table?
One.
There's one -4. Out of how many? Out of how many? 25. All right, what's the probability of getting -3? 2 out of 25. What's the probability of getting a -2? 3 out of the 25. Still not particularly likely yet, is it? All right, what's next? -1? There's 1, 2, 3, 4 of them. There's 4 -1s, right? 1, 2, 3, 4. Am I counting that wrong?
No, it's 4.
Okay, so that's 4 out of 25. The probability of getting a 0 is how many? 3 out of 25. Probability of getting a 1. 1, 2, 3. There's 4 out of 25. Probability of getting 2.
3.
It should be 3. 1, 2, 3. 3 out of 25. Probability of getting a 3. Is it just 2 out of 25? Probability of getting a 4 is also 2 out of 25. Probability of getting a 6 is only 1 out of 25. So, what would be the best thing for her to choose? Exactly right. 1 or -1. The probability for getting that sum with 2 spins is going to be 4 out of 25. All right. So now let's look at, well, what if we have more than 2 events happening? So in a power outage, Rona has to reach into her closet in the dark to get dressed. She's going to find 1 shirt and 1 pair of pants. She has 3 different pairs of pants hanging there. 1 black, 1 brown, and 1 plaid. She also has 2 different shirts that are hanging up, one white, and 1 polka dot. Now this time we're just doing 2 events still, right? You could make a probability table for this, but you can also make a probability tree. So this is your starting point, and this is all the different possibilities of the first event. So she's picking the pants, either black or brown, or what was the other one? Plaid?
It's like the checkered one.
1 black, 1 brown, 1 plaid.
Plate.
It's like the Christmas.
Plaid.
It's like the signs and it's like the it's like the Christmas. It's like the Christmas.
The red and black.
Yeah, like that.
The red and black.
It's like their skirts. Yeah, it's like
It's
their
like
skirts.
And then, all right, shh, 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 shh. And then she has 2 different shirts, 1 white and 1 polka dot. So after she's chosen a pair of pants, she has 2 choices every time, a white or a polka dot. So we want to darken the branch that shows plaid pants and a white shirt. So plaid pants, white shirt. So in part C, they ask, how many different clothing combinations are there? And where on the tree can you look to count the complete combinations? Well, there are 1, 2, 3, 4, 5, 6 different combinations. On the tree, you just look all the way to the right. So there are 6 combinations. So we're going to count the last branches. All the way to the right. All right, so what's the probability that her outfit will include brown pants? What is it? 1/3. Why? Right. There are 2 different outcomes with brown pants. Brown pants, white shirt, brown pants, polka dot out of the 6. So that's 1 out of 3. Which makes sense because how many different pants was she choosing from to start with? 3. What's the probability that her outfit will include a polka dot shirt? Well, let's look at these. This one's polka dot shirt, this one's a polka dot shirt, this one's a polka dot shirt. That's 3 out of 6, which is 1/2, which again makes sense. She's choosing 1 of 2 shirts. All right. Let's see. Okay. Let's look at this one. So when you only have when you only have 2 events, I think it's easier to make a table. It's just less messy. If you have more than 2 events, you don't have any choice. You have to make a tree. Unless you can, build a 3-dimensional model, Rubik's Cube of your choices. That doesn't sound like fun either. So Scott's job at Crazy Creations Ice Cream Shop is to design new ice cream flavors. The company has just received some new ingredients, and Scott wants to be sure to try all of the possible combinations. He needs to choose 1 item from each category to create the new flavor. So we're going to make a probability tree for this. And I'll just tell you, these tend to get messy. Okay? And one of the things you want to do is you want to make sure that you're leaving plenty of room. So in other words, when you first start, Don't make your two do something like this where they're really close together. Do not do that. Because then you're going to branch off from this and branch off from this, and everything's going to run together. It's going to be awful. If you have plenty of room, well, make those first ones a long way apart. Now, don't get crazy with it, but that's probably too long. And it doesn't have to be super long, but I don't want those to be just real close together. So that's my flavor base, vanilla or chocolate. From each one of those, we have 3 choices of chunky mix-in. So 1, 2, 3, 1, 2, 3. Now remember, from each of those, we're going to have 2 more choices. So again, don't put them super close together. So we've got hazelnuts, sprinkles, toffee. Hazelnuts, sprinkles, toffee. And from each of those, I have 4 choices. Oi, this is where it starts getting messy. It actually works better, although this was given in this order, so I'm doing in this order, if you do the one with the most choices first, right? Because then you're not having to go, oh gosh, this is all going to crowd up. So each one of these has 4. 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You can see how awful mine looks already. And there's apricot, plum, berry, and grape. You can see how really bad that looks, right? I'm going to redo mine. You don't have to if you don't want to, but I'm going to redo mine with the one with 4 choices first. And I think you'll see that it's a little nicer. That, and I don't have to write nearly as many things. So this was hazelnuts, sprinkles, and toffee bits. And then off of each of those, I have 2 base flavors, vanilla or chocolate. In the end, it's the same number of total. It's a little bit nicer, but you can see I didn't leave enough room. On a quiz or a test, I try to avoid having this many. Okay? I usually do it where there's 2 or 3, not 4 in any of them. All right, so at the end we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 different possible flavor combinations. What's the probability that this final combination will include hazelnuts? Well, let's see. How many of them had hazelnuts? 1, 2, 3, 4, 5, 6. We're looking for the hazelnut, 7, 8. So 8 out of 24. Which is 1/3, which again makes sense. If we go back to this, there were 3 choices here, and he had to pick one. Probability's final combination will include a plum swirl. Well, let's see. Plum. That's all of these. 1, 2, 3, 4, 5, 6 out of 24. Oops. Which is 1/4. So Scott's sister loves hazelnuts and Scott's little brother loves grape. How many outcomes include Scott's sister event? Well, we already said that. There were 8 of them. And how many outcomes include Scott's brother's event? There were 6 of those. 2 events are mutually exclusive if they have no outcomes in common. Do Scott's sister and little brother have mutually exclusive event? In other words, is there a possibility that you can get grape and hazelnut in the same one? Yeah. So are they mutually exclusive? No. What 2 mutually exclusive events in the Crazy Creations ice cream shop be? Well, there's lots of them. Yeah, so anything that has vanilla, so you go, vanilla, hazelnuts, plum swirl. And chocolate, sprinkles, and we'll do grape. That sounds horrible. All right, those combinations are mutually exclusive. If you've got one, there's no outcome in common. So we could list that, or we could just say, like Ben was saying, vanilla and chocolate. Those are mutually exclusive. If you have vanilla, you can't have chocolate. If you have chocolate, you can't have vanilla. Before we finish up, I want you to look at something. How many total possibilities were there? There were 24. 2 of these, 3 of these, 4 of these. How can we get 24 from those 3 numbers? Just multiply them. You can always check to see if you've gotten all of the right combinations or the correct number of combinations. Okay, any questions about that? Okie dokie.